given about 6 months ago with how to sort of provide a little bit more information on what are the risks that actually deploying a dedicated blue team would actually stop. So when we were looking at this problem in our threat intelligence lab, basically what we were looking to do was how could we actually take just like the generic nature of risk that's actually out there and decompose this into a number of different data points that we could actually support with some of the measurements that we actually have access to. So I'm going to sort of open up. I'm going to talk a little bit about where we actually source our data, what the data looks like. I'm going to sort of lay the cards on the table for what our sampling biases are in the data set that we have access to, and sort of discuss a little bit more about how we actually tackled the problem. We'll take a look, show and tell the results in this one. So the big things that we're taking a look at here are what are the chances that we'll experience a breach of like typical perimeter controls that would require some sort of SOC or blue team response action. We'll talk a little bit about how many assets we typically see being hit by breaches over the course of a year within a particular industry or geographic location. And then we'll also talk a little bit about, in the first section here, what does a breach actually look like and how are we actually responding to it, so you get a better idea of what that looks like as well. And this data set can be used to plan a number of different countermeasures. Hopefully it's useful to you in a variety of different ways, but we can talk a little bit about how we can plan effective responses, how we can keep this sort of data up to date, and maybe do a little bit of Q&A discussion at the end of this. So just to get things rolling, our data set is comprised of about 1,800 network sensors. Those are deployed at internet choke points. We are running full packet capture on them so that we can actually take a look and do forensic inspection of what it is that we're seeing. And we're running a number of different IDS tools. These are deployed specifically to take a look at what the clean side traffic is looking like after all of the perimeter controls are actually running through. On the endpoint side, for visibility there, we're talking about 87,000 endpoints that we have out there. Those are CB response agents, and we're running a number of different feeds on them for detection purposes, as well as some additional tools of our own design to try and take a look at some of the raw data in a different way. So this data set is taken from 600 or so organizations deployed around 2,000 different sites. It represents 28 industries, 50 countries, and about 185,000 plus users. Our data set, we mostly are protecting financial industries. So most of the data that you're going to see taken from our data set is finance oriented, but we also have a fairly decent sized pool of other, and that breaks down across a number of different things. So if we take a look at how that breaks down, you can see that we've got two other big sections in legal and technology, but we also have a slew of smaller data that's coming from a variety of different medium-sized organizations that are out there. We are definitely talking about mid-sized organizations here, not super large organizations. So this is about perimeter controls and what it is that we're responding to on the inside of those for that particular type of demographic. If we talk about the typical perimeter defenses, like what's ahead of us, so we're not talking about things that are being stopped by next-gen firewalls. We're not talking about things that are stopped by the IPS systems. I mean, sometimes there are things that should be stopped by those things, but these are the things that we're typically seeing deployed ahead of our monitoring service. So if we run in there, basically we're looking at things that are behind these. So on the endpoint side, typically most of our clients are also running mature antivirus or next-gen antivirus technology in addition to the CVE response agent. So we're not talking about the things that are picked up and stopped by those things. In terms of what we're actually doing, our side, we're looking at monitoring and hunting. We do periodic hunting exercises that are sort of ad hoc, where we go and we take a look at just like the raw data set and see if we can find anything else that's interesting in it. We do investigations into things that are just being picked up in triage with the internally deployed IDS to see if anything's gotten through more permissive configurations that are set up with next-gen firewalls. And then we respond. So typically, this is another part of what it is that we do, and it does actually definitely have a ramification on the data, because what we're talking about with the response is everything that we actually have as a data point represents something that we saw and did something to contain. So if we're talking about the number of assets that are impacted, this is going to assume that you are doing something to actually contain the breaches. I can't really show you stuff where we didn't have anybody engaged. And then as follow-up, after we actually detect breaches, we have a TI team that's looking at, going in and doing some additional research into those. They try and do sampling across different situations. They just sort of do follow-up analysis to get us some additional characteristics, and we can talk a little bit about that research as well. So, data point deep dive. Basically what we have here is a tool that'll just sort of let us run through what we would be talking about as a single data point within our set. So we're talking about tens of thousands of these sorts of incidents, but to sort of walk you through what one incident would look like and what the data sort of represents. This is just a malicious document. I believe it's a phishing situation that we can run through. But what it looks like is we might pick up something where we have a user who has been successfully phished, they've run a maldoc, and we see some sort of reputational indicator that says that their machine is now beaconing out to a CNC. So this is a case where we've seen phishing bypass the defenses, and we have like a reputational indicator or some other reason that's being picked up by one of our detecting technologies that's saying, hey, we need to go take a look at that. And we've got like our own sort of SIM in here, but I mean, this would apply to anybody's SIM if you were taking a look at it is just a starting point for your investigation. Then what we'd be looking at doing is sort of like reviewing what's actually going on, take a look at, just address information, start digging deeper. If we take a look at that, we can see if there's any reputational indicators that might increase the confidence that we're actually taking a look at something bad. We can talk about initial analysis where we would be getting sort of into essentially just sort of basic triage functions, and you can think about implementing these within your own SOC as well, where you're just sort of like sifting through what are the things that you would actually do deep response into, and maybe some of the things that you might discard if it's obviously benign. And then if we see that we actually have let me just take a look here. Sorry. One of the other things that you might want to use in here is contextual information about sort of things that might be relevant to your business that can also weed some of that stuff out. But assuming that we've actually done all those things and we're coming back with something that's actually interesting to take a look at, we would probably be taking a look at raw wire confirmation on our side, which would let us go into here and see, well, what communication is actually going back. We can see in this case, if we're taking a look at the traffic around it, that we're actually fetching a document down. And then when we go into it, our side for investigation, we typically look at actually extracting the file out, trying to reconstruct that either out of the PCAP, or we could be reconstructing it if you don't have access to full packet capture on your side. You could also take a look at just taking a look at like summarized data that's coming off of something like bro logs and see if you can reconstruct the domain that it was actually sourcing a maldoc from. When you have the maldoc, we typically would run some sort of sandbox analysis on it to try and get an understanding of what it actually is, what it does. There's a variety of different tools that are out there for this. I think on our side right now we're using a hybrid analysis tool. We've used Cuckoo in the past, which is an open source project, and I know there's also a number of commercial ones that are out there, but all are good things to give you more information when you're actually taking a look at it. And then from an endpoint side, you have the whole side of taking a look into it from what is actually running on the local machine. Can you actually figure out what's going on in something like CB response? Can you figure out, were there any weird processes that were spawned after they opened the document, et cetera, et cetera. So from our side, in this particular case, we're taking a look at it. We do see that we see, some post-download opening of the file, and then some PowerShell commands actually running and doing some fairly suspicious things that are actually running on that particular agent. We can see binary analysis, where we're sort of taking a look at what is actually coming down into this machine, et cetera, et cetera. So I'm sort of skimming through all of this. If we do want to go back to it and take a look, I'm more than happy to discuss it in greater depth. But I just sort of wanted to give basically like an idea of the sorts of things that actually represent each data point that's in here. So I can talk in detail about like some of the ones that we have for scenario data. This does not necessarily reflect what every single incident was, but it reflects the type of things that we're doing in order to qualify the data that you're seeing as part of the data set that we are releasing today. So just taking a look. So process inspection, what it's doing, and basically at the conclusion of sandbox analysis and all of this, what we are taking a look at from this is essentially just how do we actually classify the incident. So as the analyst is going through, they're taking a look at it, and we have a number of different incident types that we're going to talk about today in the data set. One of them is phishing. So when we talk about phishing, we're talking about something that has occurred where we've actually seen phishing hit a user, and we've either seen and confirmed that the user has submitted credentials out to the third party, or we've confirmed that they've actually followed through and installed something and run something on the machine. If we're talking about the malware incidents in our data set, what we're talking about is something where we've had an analyst go in there and confirm that we've actually seen code execute on the machine that did have some sort of malicious purpose. And from the exploit side, this is actually sort of interesting. I was looking at a talk today from Michael Reutman, and what we're looking at is we're just basically confirming that an exploit was observed on the inside of the perimeter, and it was interacting with something that it should never have been able to actually access. So it's you have a protected server, and the protected server is behind something like a next-gen firewall or a web application firewall, or maybe both, and still you're actually seeing something coming through from the internet that's interacting with that server because it has to expose something legitimate, and the exploits are actually being seen on the inside. Our typical response is basically just like basic host isolation, containment, remediation. We generally pass off to the client. But the idea here is that in this data set, we're taking a look at stuff where once we see something come through, we generally try and deny the attacker's infrastructure that's launching the attack and sort of limit the damage so that it can't spread within the environment. And when we take a look at impact data, that's going to become a lot more relevant. So if I take a look at, let's just pull back up here. Is this not? There we go. So the thinking here, we're taking a look at a data set. We're talking about tens to hundreds of thousands of investigations that look like this. And what we're trying to do is sort of see if we can draw any conclusions about what the probabilities are that we're going to see security incidents at particular locations over particular time periods. So the way that we approached this in our study was we were basically treating each sensor that we actually had that was out there as a convenient sample that's taken from a general population. And you can think about sort of subdividing your data or restricting your convenience sample to things that are more relevant to your particular industry or your particular sort of demographic. But what we're going to basically do then is we're going to record a Boolean value about whether or not the sensor was participating in one of these different types of incidents and responding to one of these types within a time window. So if we're talking about something like malware, for example, what we might do is we might start generating data points and we say, okay, well, did the sensor participate in a malware incident this month? Like, did we have to actually respond to malware on the clean side this month? Yes or no? What about if we extend that to 2 months, to 3 months? What if we look at it in March, in April, in May? And then you can think about repeating this over and over and over again for all the different types of incidents that we could be talking about and all of the different time periods that we might want to represent in the data set. So the raw data that we have is actually just going to be looking at the incidents themselves and what time that they actually occurred on. But this is sort of how you can use that raw incident data in order to make a bit of a statistical projection about what you might actually have seen if you were trying to figure out what it is that you need to go look for. So we repeat this across all these different types. And what we're basically left with is a data set that looks like a sampling without replacement data set. So you can apply a hypergeometric distribution analysis to that. And there's, I don't know actually how to reconstruct that myself, but fortunately there are wonderful libraries in Python that will apply that statistical pattern to the data. And then what that can do is it can let us take a look and see what the confidence interval would be projecting from data set that we have, which is our observed rate, to a projected best case and worst case scenario for what we can think about the general population having if we're deciding whether or not we actually want to deploy a sensor into a particular area, or if we're deciding, trying to make maybe a budget case to somebody about, maybe I would really like to implement a monitoring program and I'm having difficulty actually justifying the budget, then you can take some of this data and maybe build it into a case like that. So if we think about how do we actually gather the data, assess potential impact from security incidents over a time period, that was a bit of a tougher problem in the risk side. Like if we think about risk, we're talking about impact, we're talking about probability. We've sort of looked a little bit about probability right now. The question is, how do we actually address impact? And ultimately, this was an area that we found a bit harder. So I'm going to share the data that I have, and I'm hoping that you guys out there will have some data about your environment from your side that can help you add to this data and think about what the impact would actually look like in your environment. But what we can do is we can show a distribution curve of what the number of impacted assets and users were from our data pool. So if you think about what it is that we're doing in response, when we detect an incident, we're trying to contain it as fast as possible, and then we're basically creating a log of how many different assets were actually impacted. So sometimes when an incident comes in, it'll spread. Sometimes people will not be able to repair a hole in their general perimeter configuration, and we'll see a repeat of the same type of breach that comes back over and over and over again. But you can think about those numbers that we have in our data set, basically just sort of giving you sort of like an impact distribution for the number of affected assets that we see from different types of activity. We also have some data about what is going on in a breach. So we have demographics on things like what lures are people actually using for phishing over different time periods. What are the success rates of each? What malware is deployed if a machine actually does get popped and somebody runs a doc on it. So we have some data with that as well that we can share. So if I take a look at actually showing the incident probability, what we were doing, let me just see here. So this is essentially the output of that statistical analysis. It's just been put into a tool that we have up on our website where you can take a look and you can actually run some different filters over the data, and you can say, well, what does the rate of breach look like for, say, all of the different client pool, or maybe just like the client pool in the tech industry or the health industry or the insurance industry, and then sort of basically draw some comparisons around that. So if we take a look at it, there is some interesting stuff that we can actually see. So this is just one view on the data set. We ran it as two different things. One was instantaneous because we were curious about what was the sort of the trend line. So if we see that there's a sudden spike in trending information, then that can give us an idea that maybe a particular type of attack is starting to become more successful. And we can see that in general, for most of the incident types on a global level over the last year, it's been fairly steady. We can also do sort of a analysis of which types of incidents are more likely than others to occur on any given month. So it looks like malware and phishing are sort of going back and forth. We're seeing that the rate at which we see malware incidents is a little bit higher than the rate at which we see, for example, general phishing. But exploit being seen on the inside of the firewall because something's allowed an exploit attack to actually get through is significantly higher than either of the other two. And that is a pattern that we generally see consistently across most industries. There are a few exceptions. One of the things that was really interesting in this data set was that when we compared things like the UK data set versus like the North American data set, some of the trends actually flipped around and reversed. So in the UK, it's significantly more likely to see phishing than it is to see malware actually be successful. But there's that. What we're doing here is we're actually plotting an average case, a worst case, and a best case. And the way that we're doing that within our data set is we're essentially just looking at the confidence intervals. So if we're thinking back to that hypergeometric distribution calculation, it's going to output basically a upper bound, a lower bound, and a confidence rate that you can say that you're actually going to see that in the general population based off of what you observed. So we're running a best case projection would basically be the bottom of that confidence interval, and then the worst case would be the top of that confidence interval. So with the tool, basically, you can move around inside of that data and sort of see what it is. You can compare a number of different industries. So for example, maybe I wanted to do a comparison, and I'm maybe a finance client, and I'm considering partnering up with a insurance client, and I kind of want to see whether my risk rates are about the same as their risk rates in terms of general health. So we can take a look at this, and you can sort of compare what those actually look like. It's a little chaotic if you look at all of them together, but maybe we just want to compare the rate for, say, malware between the two. And you can see that there's different rates that are actually in here. The other thing that you can do with this, which we thought was interesting, was show cumulative rates of breach for particular types of incidents. So we were looking at it month over month, and what we realized was that the month over month rate is actually quite a low percentage. Most of the time, you're not going to see a breach that actually shows up on the inside on a monthly level, but If we take a look at that over the course of an entire year, your percentages start to change. And they also start to change if you start to think about managing more and more sites. So, I mean, intuitively, this definitely makes sense. If you have lots of different locations that you have to protect, and you think about, running your defenses on your regular cadence over the course of an entire year, what are the chances that somebody screws up in one of those locations and maybe, misapplies, an update to the signatures that are running on your next-gen firewall? Well, your rates actually change on that one. So the variables that you can input into the tool, you can see whether you're talking about a cumulative case, you can see whether you're talking about an instantaneous case if you're looking for trend data, and you can also configure basically, how many different sites that you would like to be talking about inside of the data set. The next section that we actually have in the data, and this is where I was coming back to that impact data, is we can talk about how many actual assets are impacted by various different types of breaches over the course of a year or any other particular time period. This particular set is looking at yearly impacted assets, but you could just as easily from the same data set do it over a monthly or a quarterly basis or whatever it is that you wanted to actually project out. And we can see that there's definitely different types of distributions that are out there, but what we're basically seeing here is that we have a cluster, and there's sort of a long tail distribution for most things, where your average organization that experiences something where we're seeing, like, say, exploits showing up on the inside of the perimeter is probably talking about 20 or fewer different systems that are actually susceptible to those exploits that are actually getting through. And then you can think about people who are on the tail end of the distribution curve, who are, in this case, looking at like 900 different machines that are actually experiencing something. These are probably people with much poorer configurations at the perimeter, right? So this sort of gives you a band, if you think about how regularly you actually apply your patch schedule, if you think about how regularly you are, updating your perimeter defenses to block out anything that's known bad from actually reaching servers and attempting exploits against them. This can give you an idea of sort of what that distribution looks like. So let's see if I can do this without it. That's through all this again. Incident demographics in this. So I've actually, so we have the tool data. I've also got it pulled up in here. And the reason why I wanted to do this was because we can also think about what sorts of different types of exploits are there. So the data set that we're releasing today is one where you can take a look at what are all the impact distributions for these types of incidents. We also have companion papers for threat intelligence that are talking about what are the specific types of things that we see. Those are done on something where they're I think generally released on a quarterly basis. All of this data is freely available to everybody as a practitioner, so if it's something that you're interested in, it's not something you have to pay for. But we're breaking it down in terms of what we're actually seeing in terms of the campaigns that are actually getting through. And you see that there are some things which are very popular, which are actually still coming through onto the clean side. In this particular instance, when we were running this, this is just looking at some data showing it's we have the Microsoft IAS stuff and the WebLogic stuff that's coming through fairly high volume, and then we have a tail end distribution of a lot of other different types of exploits. In a similar way, we can think about what are the different types of things that people are actually running on the machine when they actually have access to it. And we can see that right now, Emotet has been enormously popular for people to actually choose to actually run on a machine once they actually get access to it. But we do see a lot of other different types of tools being run sort of in again, that sort of long tail distribution where you see little bits of lots of different types of activity that's coming through in there. Phishing. So, I mean, there's lots of different data that you have on phishing. Realistically, this is probably one of the most popular ways to actually breach in because you can successfully get a user to do something stupid just about all the time. And it's an attack that never really gets old. But one of the things that we were looking at here is maybe we can talk about some data about when you can think that you would have more likely for people to actually convert over and engage with phishing, and what are different ways that we can actually take a look at it. So we can see that there are some days of the week where there's actually significantly less chance that people will actually engage with a phishing campaign, and other days of the week where there's almost twice as high a percentage of them engaging with the phishing campaign. So this looks at basically just link clicked and credentials actually submitted out of the phishing data. We can also think about like what lures we actually see are being more effective. So, what we see the most of in terms of lures, and then what we see are most successful in terms of people actually clicking and engaging with them. So again, if this data is something that is of interest to you, there is a whole bunch of additional stuff that we actually have within there. So ways to use this, runbooks, next steps, that kind of stuff. So really when we were putting this together, there's a couple of different people that we were sort of thinking about. Well, one, if you are already well represented by one of the convenience samples that we've calculated for you, please feel free to use the work that we've actually produced inside of here. But otherwise, we have the raw data set, and say you are, maybe a mix of like industry and financial. So you just want to see like a mix of those two different data sets blended together. I'm hoping that you can take the raw data that we're putting out there, you can blend those together into a convenience sample that sort of represents what it is that you want to represent with it, and sort of repeat the methodology that we've discussed here today in order to give you some better predictions that you can use for your own threat intelligence purposes, or again, if you're trying to justify in terms of like a management decision, like what your blue team needs in order to actually do something. And then the impact data, obviously you're going to have to do a self-assessment of how flat your environment is and how quickly you actually respond to one of these things when you see something get popped inside of your environment. If you respond relatively quickly and you contain it fairly effectively, or you have like lots of great network segmentation, then you're probably going to see something where you have a fairly similar impact distribution on the left-hand side of the curve. If you're somebody who is in the unfortunate position of having to do security for a completely flat network environment with no permissioning and no least privileges, none of that great stuff, then you're probably going to see something towards the extreme tail end where a lot of assets are getting impacted. But it's a good way to actually show what that range can actually look like. So at this point, if anybody is interested in the actual data set and contact, that's the link up there. And then the QR code is just a repeat of the link if you are interested in pulling it down. But with that up there, we have a fairly small audience today. Does anyone have any questions with anything that I could go into or explore?
What would be some stuff we could use the data for, right? Like you mentioned run bugs, maybe we can talk about an example of that. See that IIS points are up there, and maybe talk about how you handle that.
Yeah, so that's a good question. So if we're thinking about this, the idea is to try and give you an idea of sort of what are the probabilities that you'll run into different things, so that you can kind of prioritize what your blue team activity should be. If we're thinking about a run book, one of the things that we can do is we can basically detail out what are the general investigative steps that you'd have to take along the way at different stages in order to actually respond to one of these actually being detected. So if we think back to this phishing example that we have here, there's a number of steps in here that we can think about that you would have to do for basically every one of these detections, right? So this is one where we're basically just looking at a block of a file, block download, where somebody's attempting to download from something that we've got a reputation indicator for. But if you think about each of the steps that are on here, these are very highly automatable things that you can actually take a look at doing repeatedly within your organization. So a lot of people are starting to look at SOAR platforms in order to start to automate these tasks and increase the fidelity of the signal that the analysts are actually having to take a look at when they go in to do it, so they don't have to do so many of these things by hand. But we can think about collecting data about what is it that this particular incident is actually having. So pull down data about the IPs, pull down data about the files. All of the steps in this are things that we can think about doing in an automatable sort of way. So you could do a run book where, for example, you were to take the indicator, you were to look at it, you were to maybe extract a PCAP around it, you would maybe automatically submit the files within for analysis inside of your sandbox application. And then maybe the analyst at the other end, instead of having to repeat all of these steps, is just looking at a report where they can see everything that's on, and maybe they can just move into a judgment sort of situation.
Yeah. Previous talk, someone raised the question of instead of just counting the number of assets,
Yes.
if you could put a dollar amount on those assets, is there any thought about trying to incorporate? Because not all assets are equal, right?
I would 100% agree with doing that. We often don't have a dollar value to assign to the assets that we're protecting. So we're outsourced, so we're not in a position to do that. But if you're looking at it from your side, and you are like a practitioner who's protecting just one environment, 100% I would definitely do that. I would also take a look at like when you're applying that sort of dollar value, think about the data that's on there, and think about the cost of remediation as two other costs that you would plug into that for your impact assessment.
And also reputational, regulatory fines, et cetera, et cetera.
Yeah. No, it can definitely skyrocket up there, and in some cases it can be almost nothing. So, any others?